This is the Algebra 1 with Lab video on inequalities. This is only part of what's going to be covered on the second exam. Word problems will be covered, and I've already made a movie on word problems that you can go back and look at. I'll post the link also on Edline. But this is a specific review on the topic of inequalities. So our first question is, which number is a solution to the inequality negative 3x minus 13 is less than 2x plus 7? So here's my inequality. Okay. I solve it like an equation. Okay. I'm going to solve it like an equation. So I want to try to get all my x's on one side and all the numbers on the other. So the first thing I will personally do is subtract 2x. And what that will do is I want to make the left side my x's side and my right side the numbers side. So negative 3x minus 2x is negative 5x. Do that in the calculator if you're not sure. And I'm bringing everything down. So notice when I do negative 3x minus 2x, I wrote the result right here. And I'm bringing down my negative 13. That's less than the 2x minus 2x is 0. So we don't have to write it anymore. It cancels. And I'm going to bring down my 7. Notice I wrote the inequality symbol. That was there. I didn't change it. I kept it. I didn't change it to an equal sign. I didn't do anything to it. All right. Now we'll add 13 to both sides. That'll get that 13 away from the x's side and onto the number side. And again, negative 13 plus 13 is 0, so it cancels. And I'm going to write everything down. So I'm going to have negative 5x is still less than 7 plus 13 is 20. One more step. I have negative 5 times x. To do the opposite, I will divide both sides by negative 5. Here's where you just have to remember one little thing. When you divide or multiply by a negative, so let me actually write like this. I need to reverse the inequality or flip the inequality. So I'm flipping the inequality when dividing by a negative. So notice the negative sign is in the thing that I'm dividing by. It doesn't have to be in the 20. It has to be in the number in the bottom that I'm dividing by. So the negative 5s will divide to 1, therefore canceling. I will get x. Because we divided by that negative, we're going to reverse the inequality symbol. So it goes from a less than to a greater than. And 20 divided by negative 5 is negative 4. That is the solution to the inequality. However, I'm looking for a particular number which is part of the solution. So x is greater than negative 4. One thing that really helps is to graph this on a number line. So I'm going to do that right here. I'm going to graph this thing on a number line. Okay. I always told you to put 0 on your number line and put negative 4, which would be to the left of 0 on your number line. It's a strictly greater than. There's no equal part to it. So I'm going to use an open circle. And I'm going to shade to the right because x needs to be greater than 4. Think about the keys on the piano. The higher keys are to the right. Now, I have to ask myself, which number is greater than negative 4 out of the choices? And everybody always chooses negative 4 because you see that. Oh, look, it says negative 4. But you have to remember, it's an inequality. So you have to be careful. If I looked at my choices, negative 3 is right about here. If you notice, that's in the green portion. That's in the shaded region. That's a solution. There's an open circle on negative 4. What that means is that negative 4 is not part of the solution. Another way to understand that is negative 4 greater than negative 4? Well, no, it's not. So it's not part of the solution. Negative 5 and negative 6 are to the left of -4. They're nowhere near the green shaded area. So the only value that's in that green shaded area is the -3 out of the choices that we were given. The other ones are not. So -3 is the final answer. Again, -4 is not the answer. Everybody did this problem and they chose -4. -4 is not greater than -4. This inequality right here is not true. So don't get fooled by that. All right. Number 2, another type of question like this. Which number this time is not a solution to the inequality? So I want to write the original inequality as I see it. It's 14n minus 46 is less than or equal to 2 times parentheses 7 minus 8n. And I'm going to solve this just like I would an equality or an equation. So I have 14n minus 46, and I'll distribute on the right-hand side to get rid of the parentheses. So 2 times 7 is 14, minus 2 times 8 is 16, and we have 16n. This time, I'll choose this side to be my n's, the left side, and the right side to be my numbers. So I'm going to add 16n to both sides. And I'm going to write very neatly, 14n plus 16n is 30n. Bringing down my minus 46, bringing down my inequality less than or equal to. The 16n and the negative 16n add up to 0, so they, quote, cancel, and I have my 14. I still have numbers and letters on the left. I'm going to add 46, so the numbers are all on the right. So I have my 30n, the negative 46 and the 46 cancel. That's less than or equal to 14 plus 46, which is 60. Divide both sides by 30. And since we're dividing by a positive, we can leave the inequality symbol alone. Unlike the last question, where we were dividing by a negative quantity, dividing by the negative caused us to change the inequality. This time we do not need to do that because we're dividing by a positive 30. So I do not need to change the inequality. N is less than or equal to 2. Now it says which number is not a solution to the inequality. I'm going to graph this on a number line because it's helpful. I have my 0 in the middle, 2 is to the right, less than or equal to 2. I have an open circle, closed circle, because 2 is less than or equal to 2. Or if I see the equal part, I fill in the circle, and I'm going to shade to the left. That's the direction for less than. And I look. I want which number is not a solution. Which number is not shaded in the green area. So I look at 4. 4 is to the right of 2. 4 is not in the solution. That's the answer. 2 is in the solution because for 2 reasons. One, this circle is filled in. That means 2 is part of the solution. The other reason is that if I say instead of n is less than or equal to 2, if I plug in 2 for n, I'm saying 2 is less than or equal to 2, and I'm asking myself, is that true or false? Well, that's true. That works. Okay? Negative 2 is down here, and negative 4 is right about there. Those are both in the green area. So those are solutions. So the only one that's not is positive 4. So choice 1, positive 4 is the answer. All right, number 3. What is the solution to the inequality? This one's a little easier because they just want you to get down to the inequality and report the answer. So 15x minus 24 is greater than or equal to 8x plus 11. So again, I'm going to use x's on the left, numbers on the right. I'll subtract my 8x. I'm going to go a little faster through this one. So it's 7x minus 24 is greater or equal to 11. Add 24 to both sides. Bringing down everything, 7x is greater than or equal to 35. Divide by 7 on both sides. I don't have to do anything fancy to the inequality because I'm not dividing by a negative. 35 divided by 7 is 5. And so x is greater than or equal to 5. Choice 2 is the final answer. Number 4, what is the solution of the inequality? Very similar type question. So we have 3d minus 22 is greater than 5 times parentheses 2 minus d. We'll get rid of the parentheses on the left-hand side, the right-hand side by distributing. Distributing is multiplication. 5 times 2 is 10 minus 5d. And again, I'll pick this to be my d's, the left-hand side to be my d's, and the right-hand side to be my numbers. So I'll add 5d to both sides. 3d plus 5d is 8d minus 22 is greater than 10. Add 22 to both sides. 8d is greater than 32. Divide by 8. And d is greater than 4, which is choice 4. Now, I'm going to do this problem a little differently, okay? So I'm actually going to clone this page. Hold on here. Nope. There's another approach to this problem that if you start off differently than I did, you're going to run into a couple of issues that you know how to handle, but I want to address here. So our first step again, I'm just doing the same problem again, but a slightly different way, because that's maybe the way that you did it. We're going to still distribute, so we're going to get 10 minus 5d. Now let's say for a minute you decided that you are going to subtract 3d from both sides, which is totally fine. Okay, this is a totally legitimate way to do the problem if you know how to finish it. So 3d minus 3d is 0. I get negative 22 is greater than 10 minus 8d. Okay, so now I'm doing my numbers on the left and letters on the right, which is okay as long as you know how to handle it at the end. I'm going to subtract 10 from both sides, and I'm going to get negative 32 is greater than negative 8d. And this is where it can get a little confusing. I need to divide. This time I need to divide by negative 8. Negative 8. So what needs to happen is, because I'm dividing by a negative, I need to change the inequality. So if negative 32 divided by negative 8 is 4. I need to flip the inequality. So right now it's a greater than. I need to change it to a less than. And negative 8 divided by negative 8 is 1. So we get 4 is less than d. That's from the negative that we're dividing by. Okay? Now, this 4 less than d does not read very nicely. Okay? We need to change that so that d comes first. So here's my analogy, okay? 4 is less than 7. We can all agree on that. Now let's say I wanted to state the same idea with the 7 first. Well, I couldn't put a less than in there. 7 is not less than 4. 7 is greater than 4. So instead of having the 7, I had the d. That's all. So I'm going to put a d there. Okay. So if 4 is less than d, then d had to be greater than 4, which is choice 4. So again, either way works, this way or this way. The only thing with this method is that you need to remember two things. You need to remember, one, flip the inequality when dividing by a negative. And two, rewrite the inequality. What I mean is this. You have to rewrite the inequality with the d first. All right, number 5. What is the solution to this inequality? I'm going to go pretty fast through this. So negative 5, parentheses 2y plus 7 minus 2y, is that less than or equal to 1? So distributing, negative 5 times 2y is negative 10y. Negative 5 times 7 is negative 35. Minus 2y is less than or equal to 1. And my analogy is always, you need to clean up your room before you go out. Meaning you need to clean up the left side before you move anything around. So I have like terms. I have my negative 10y and my negative 2y, and I'm adding them. Negative 10 plus negative 2 is negative 12y. Then I have my minus 35, and I have my inequality less than or equal to 1. Add 35 to both sides, and we get negative 12y is less than or equal to 36. And I'm dividing by negative 12. And again, if I'm dividing by a negative, okay, dividing by a negative, I must make sure to flip the inequality if I'm dividing by a negative. So I have y. Instead of less than or equal to, it's going to become greater than or equal to. 36 divided by negative 12 is negative 3. So y is greater than or equal to negative 3 is the inequality, and that looks like it is choice 2. And notice, all the little tricks are there. In number 1, the choice never flipped the inequality. In number 3 and 4, they kind of made you forget that you're dividing a positive by a negative. So all the little things that you can mess up are going to be choices. That's on purpose. That's to see if you really understand what you're doing. All right, number 6, which is a solution of 2x plus 5 is greater than negative 1. So we'll solve the inequality, and then we have to look for which number makes sense in the inequality. So we'll subtract 5 from both sides. We'll get 2x is greater than negative 6. Divide by 2. Since we're dividing by a positive, no need to flip the inequality. X is greater than negative 3. I'm going to make a number line because I'm looking for which is a solution out of the 5 choices. So I'm going to put 0. I'm going to put negative 3 on the number line. Open circle, and I'm shading. I want to do this in green. Open circle and shade to the right. Now, which is a solution? Well, the solution has to be in that area. If I look, negative 6 is over here, not in the solution. Negative 5's over here, not in the solution. Negative 4 is over there, not in the solution. Negative 3, since it has an open circle, is not in the solution. Another way to say this is negative 3 greater than negative 3? It's not. So negative 3 is not in the solution, so these are all out. And negative 2 is the only one that's part of the green shaded area. The rest of them, the negative 6, the negative 5, the negative 4, the negative 3 are not. Negative 2 is. So that is a solution. All right, number 7. Which graph shows the solution? So now we have to actually be able to pick the graph out. So again, we'll distribute on the left-hand side. 2 times 6x is 12x. 2 times 1 is 2, which is less than 7x minus 13. I will pick the x's to be on the left, so I'm going to subtract 7x from both sides. And I get 5x plus 2 is less than negative 13. And now I'm going to move all my numbers to the right. So I'll subtract 2. I get 5x is less than negative 15. Divide by 5. I'm dividing by a positive. No need to flip the inequality. So if x is less than negative 3. Now, which graph looks like that? Well, I need an open circle on negative 3. Those choices are gone. And I'm shading to the left. Less than is to the left. That's the direction the inequality kind of points to. If you think of it as like the arrow point, it points to the left. So choice 1 is our answer. All right, number 8 and 9 are about a word problem, okay? Whoopsie, sorry. Hold on a second here. There we go. I don't want to cross that out. Okay. As part of his fitness plan, Jack wants to consume no more than 1,900 calories per day. No more than is a phrase for an inequality, which we'll deal with in a second. It says, so far today, he has consumed 360 calories. He intends to eat 5 more small meals today. What is the average number of calories he could consume per meal? It's a word problem, so I'm going to set up my columns. Okay. My setup column has to consist of the various parts. So Jack can consume no more than 1,900 calories. So this is the number of calories Jack can consume. 360 calories is what he's already eaten. So 360 is number of calories eaten. He's going to eat 5 small meals, and we want the average number of calories per meal. This is the question, so I want to call that x. X is going to be the number of meals. I'm sorry, that's not correct. X is the number of calories in each meal. And how many meals is going to eat? 5. So for example, if each meal was 100 calories, okay? Let's say each meal was 100 calories, and he's eating 5 of them, I would do 100 times 5 to get 500. Or 5 times 100, I should probably write, to get 500. But I don't know that each meal is 100 calories. So I'm going to replace that with x. And so 5x is the calories from the 5 meals. So now I need to think. If I look at his day, he's eaten 360, and he's going to add on 5 meals, okay, that are each worth X calories. That's going to be his number of meals for the day. That's going to be the number of calories he's going to consume in the day. He can consume no more than 1,900. Okay? If I just had the words more than means greater than. No more than is the total opposite. Well, what's the total complete opposite of greater than? It would be less than or equal to. No more than is actually less than or equal to. The number of calories can be no more than 1,900. The number of calories has to go up to 1,900, and that's it. Okay? No more than is the complete opposite. So here is the inequality that we could write. And notice, none of my choices really match. Because, first of all, they use the letter C instead of X. That's okay. I just chose X because we always choose X, but you can choose C. And they also rewrote these in a different order using the commutative property. So I can say 5C instead of X, I can call it C, plus 360 is less than or equal to 1,900, which is choice 4. Okay? The other choices, if you notice, choice 1 has the wrong inequality. Choice 2 is subtracting the meal he already ate. And choice 3 is assuming kind of like he had 5 meals of 360 calories, which is garbage, okay, because you would distribute that 5. So choice 4 is correct. Then it says which sentence is the solution. So all we have to do is solve this blue inequality. So we'll subtract 360 from both sides. We get 5C is less than or equal to 1,650 divided by 5. And C is less than or equal to, let's take a look. It should be 3. Give me a moment here. Whoops. Sorry, folks. This is just not good subtraction. Sorry. This is 1540 divided by 5. I was thinking of a different problem in my head. And this comes out to 308. So C is less than or equal to 308. Choice 2. All right, number 10. Whoops. Number 10. Which value of n is a solution of both inequalities? This is tricky. I have to solve both inequalities, so I want to do both of them. I want to do them separately. Distribute the 3. I get 3n minus 9 is less than or equal to 4. Add 9 on both sides. I get 3n is less than or equal to 13. And divide by 3. And this is going to get a little tricky. If I plug in 13 divided by 3 on my calculator, I'm going to get 4.3 repeated. okay? And I'm going to draw the number line for this, okay? Here's my 0. Here's my 4.3 repeating. And I'm going to shade, fill in the circle, and shade to the left. Now I'm going to do the other inequality, which was 4 times, parentheses, n minus 2 is greater than negative 1. Distribute, I get 4n minus 8, which is greater than negative 1. Add 8 on both sides. I get 4n is greater than 7. And divide by 4. And n is greater than 1.75. So here's my number line for this inequality. My 0, I have 1.75. Open circle, and I want to do this in green. I'm going to do this in red this time. Shade to the right. Now I need my number, whatever the answer is, to be in both the green and the red. So the green, let's see. I'll take 1 for example. 1 is in the green on this number line, so 1 works. But on the red number line, 1 is not in the red. So 1's out, not the answer. All right, 0. 0 is in the green, like it, but it's not in the red. Don't like it. 5. 5 is not in the green. Automatically don't like it. It's got to be in both. The word both. 2. 2. It's in the green. Check it off. And 2 is going to be to the right of 1.75. Here's my 2. It's in the red. 2 is in the green and the red. And then 6. 6, not in the green. Not part of the solution. So D is the choice that works for both. That's a tricky question. I wouldn't put anything quite that complicated on the test. But that is something that you could do. All right, number 11. Negative 2 is not a solution of which inequality? Okay? So here's my A inequality. Here's choice A. This time they gave you the inequalities as choices. So B minus 3 is less than 4. Add 3 to both sides. B is less than 7. Well, is negative 2 less than 7? Yes, it is. That's true. If you're not sure, draw a little number line. Here's my 0. Here's 7. Open circle around 7. Do this in green. Shade to the left. And negative 2 is in the green shaded region. So it is a solution of that inequality. So this is not the answer because we want which guy is not a solution. All right, B. X over 3 is greater than 1. Well, how do I get rid of division by 3? I multiply by 3. So now we have x is greater than 3. Well, if I drew my number line for this, I would have 0, 3, and I'm shading open circle on 3, and I shade to the right. Well, negative 2 is over here, not in the shaded region. So it's not a solution to that inequality, and that's the answer. I'm not even going to bother with the other ones. It takes too much time. All right, number 12. Which of the following is not a solution to that inequality? What's nice about this is they already gave you the inequality. I just have to graph it. If y is less than or equal to negative 1, here's my 0. Here's my negative 1. Less than or equal to, I fill in the circle, and I shade to the left. I have negative 3 in there. Negative 3 is a solution. Negative 1 is also a solution because the circle is filled in, and if I filled in y with negative 1, is negative 1 less than or equal to negative 1? Yes, it is. Is negative 6 a solution? Yep, negative 6 is just more to the left. So that's a solution. And 0 is not in the green area, so 0 is not a solution. So you will get a couple of problems like these, like where you have to figure out which number is or is not part of the solution. All right, number 13. What is the solution set of 2x minus 3 is less than 5 when the replacement set is the set of non-negative integers? That sounds very bizarre. So you know what we're going to do? We're going to solve the inequality first, and then we'll talk about the words. So here's my inequality. 2x minus 3 is less than 5. Add 3 to both sides. I get 2x is less than 8. I'll divide by 2, and x is less than 4. Okay? So I have x is less than 4. I'm going to graph that. Here's my 0, here's my 4, and I shade to the left. Now, it says, what is the solution set of that inequality when the replacement set, meaning the answers, is the set of non-negative integers? Non-negative and integers. Two different words, two different meanings. Non-negative. Well, negative means numbers that have a negative sign. Non-negative means numbers that don't have a negative sign. So like your positives, for example, 1, 2, 3, 4, 5, 6, all the way up. Okay, and this is where everybody gets messed up on this. 0 is non-negative. Doesn't have a negative sign. Integers are non-decimals. So these green numbers that I wrote are the non-negative integers. 0, 1, 2, 3, 4, 5, 6. 6.2, for example, would not be a part of them because 6.2 has a decimal. So I'm looking for non-negative integers. So firstly, 0 is where I could start. 0 is non-negative. What's the next one up? Well, 1's non-negative, and 2's non-negative, and 3's non-negative, and 4 is non-negative, and 5 is non-negative, and 6 is non-negative, and so on and so forth. But I need to make sure that these non-negatives are in the green area, the green shaded region. Well, 0's in the green, 1's in the green, 2's in the green, 3's in the green, 4, since we have an open circle, 4 is not in the green. And 5 is clearly not in the green. And 6 is not in the green. And neither is anything above 6. So look, I now have my collection of non-negative integers that are in the green, which is 0, 1, 2, and 3. Choice 1. Kind of a tricky worded question, but you kind of have to be able to get through those words. All right, 14. Which graph shows the solution of the inequality negative 3n plus 7 plus n is less than or equal to 11? So I have my like terms. I need to clean up my side. I have negative 3n plus 1n. Let me just write that a little neater. Plus 1n. Negative 3n plus 1n is negative 2n. Plus 7 is less than or equal to 11. Subtract 7 on both sides. Negative 2n is less than or equal to 4. Dividing by negative 2, we get n. We're dividing by a negative, so our inequality will change. It will flip. Will be greater than or equal to negative 2. The number line for that needs to be filled in at negative 2. So choices 1 and 2 are filled in at 2, not negative 2. And I'm shading to the right. That's the direction the inequality is pointing. Choice 3 shades to the right. Choice 4 shades the wrong way. Number 15. Which of these numbers is a solution for 12 minus x is less than or equal to 7? Again, another very similar type question, maybe a slightly different wording. I'm going to subtract 12 on both sides. And I will get, be careful here, the negative is attached to the x, so that stays, which is less than or equal to 7 minus 12, which is negative 5. The number in front of the x is really a negative 1. I'm dividing by negative 1 on both sides. So I get x. I'm dividing by a negative again. So I will change the inequality to read greater than or equal to. And negative 5 divided by negative 1 is 5. So my solution this time is x is greater than or equal to 5. I'm going to plot that on my number line. 0, 5, greater than or equal to. I fill in my circle at 5, and I shade to the right. So is 2 in there? Well, and I'm just going through the choices. 2, actually, let me put 2 a little closer in. 2 is not in the shaded region. And neither is 1. That's the next choice. And neither is -3. Now the answer has to be 5. Now 5 is the answer because we have a filled in circle. Or if I wanted to look at it like this, I have my inequality here. I can say, is 5 greater than or equal to 5? Well, they're equal. So yes, this is true. So 5 is the answer. All right, number 16, another one. Which number is in the solution set of 5x plus 3 is greater than 38? And by the way, they love this type of question on the regions. That's why I've given you so many of them. So 5x plus 3 is greater than 38. Subtract 3 on both sides. We get 5x is greater than 35. Divided by 5. X is greater than 7. Draw a number line. I mean, it's like once you've done 12 of these, you've done a million. So between, we're going to shade greater than 7, open circle on 7, shade this way. Is 5 in there? Well, 5 is between 0 and 7. Nope. And I'm going through the choices again. Is 6 in there? Nope. Is 7 in there? This time 7's not because there's an open circle, and also, if I tested, is 7 greater than 7? Nope. So these are out, 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 and 8 is obviously the answer, but 8 is in the shaded region. Okay? 8 is greater than 7. All right, number 17. An elevator can hold no more than 2,000 pounds. If a 350-pound package is placed on the elevator, how many people averaging 150 pounds each can safely get into the elevator? Word problem, I have my columns. Okay? The elevator can hold no more than 2,000 pounds. So 2,000 pounds, okay, is the pounds or the weight, the total, I want to call this the total weight the elevator can hold. Okay? We have a package in there of 350 pounds. That's the weight of the package. And how many people averaging 150 pounds each can safely get into the elevator? So we're looking for how many people. That's going to be our variable. So X is the number of people in the elevator, or that can be in the elevator. And they each average 150 pounds. So, for example, and I want to do this on the side here. Let's say I had 3 people in the elevator. How much weight do they account for? I would do 150 times 3. If I had 7 people in there, I would do 150 times 7 for the amount of weight. So if I have X people in there, I'm going to do 150 times X. So 150 times X is the weight, or the total weight of the people in the elevator. Okay? Now I know some of you don't have to break down everything like this, but for some of you it's very helpful. So if you come up with the right equation for this kind of problem, I'm fine without you having to write such a detailed setup. But if you can't, you better write the setup so I can give you partial credit. All right, so now I need to kind of make this happen. The elevator can hold no more than 2,000 pounds. No more than is the opposite of more than, which is less than or equal to. So the elevator can hold less than or equal to 2,000 pounds. Okay? Now, what does that consist of? Well, I had the package. Package is just sitting on the floor. Someone's got a package in the elevator. I got my 350. Plus, I have the weight of the people in the elevator. It's not the number of people in the elevator, it's the weight. So I want to add 150x. So let's think about this for a minute. 350 is in pounds. 150x, that's the weight. 150x is the weight. That's in pounds. 2,000, that was the total weight. That's in pounds. I'm consistent. Pounds plus pounds gives me pounds. If I add x in here, that would be pounds plus people. We can't add pounds to people. Okay, you can't be like, there's a package of 350 pounds and plus one person makes 351 pounds. That doesn't make sense. So you have to keep your units. It's kind of like the dollars. When we did the money word problems, everything was in dollars. Now everything's in pounds. It's the same idea. All right, solving this, we're going to subtract 350 from both sides. And we get 150x. Let me do this in black. 150x is less than or equal to 1650. Dividing by 150 on both sides. X is less than or equal to 1650 divided by 150 is 11. Okay. So how many people can get safely into the elevator? Well, X is less than or equal to 11. So how many people could be in the elevator? Well, I can have any number of people less than or equal to 11, which would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11 people. If you just wrote 11 people, I would accept that as well. Okay? But that's the number of people that could be in the elevator safely. Or any number of people less than or equal to 11. The follow-up question says, can 12 people, each weighing 150 pounds, get safely into the elevator with the 350-pound package? Explain. Well, not according to our problem. Not according to what we just did. So no, I would say, and I want to explain this two ways. No, 12 people cannot get safely into the elevator because only 11 or less people can fit safely into the elevator. Another way to justify or explain your answer is to say, well, if there were 12 people, how much weight would the elevator have? And the answer to that question is pretty easy. The answer to that question is, well, I have my 350-pound package plus 12 people who weigh 150 pounds each. So that would be 150 times 12. Well, this is 350 plus, on your calculators, you do 150 times 12, which is 1,800. 1,800 plus 350 is 2,150. So this is in pounds. Okay? So I would say another reason is if there were 12 people, it looks like weave, sorry. If there were 12 people on the elevator, then the elevator would have 2,150 pounds on it, which is too heavy since the elevator can hold only 2,000 pounds. That's an alternate way to explain why the elevator cannot hold 2,000 pounds. Sorry, 12 people. All right, a couple more problems here. Number 18, Bart is saving money to buy a flat screen computer monitor that costs $345. He has already saved $37. What is the least amount of money Bart must save each week so at the end of 11 weeks he has enough money, excluding tax, to buy the monitor? So it's a word problem. I'm going to set it up, my 3 columns. Well, $345 is the amount or the total amount for the monitor. for the monitor. By the way, a monitor is like a computer screen, so if you weren't sure about that. $37 he's already saved. It's kind of like when Liz wants to save up for her iPhone. $37, money Bart has saved. How many weeks? Well, he's saving for 11 weeks. 11 is the number of weeks. So this time we actually have the number of weeks Bart is saving for. And it says, the question is, how much money, what's the least amount of money Bart must save each week? So X is going to be the amount of money Bart saves per week. But we know that he's saving for 11 weeks. So for example, let's say he saved $2 a week. 11 times 2 would be the amount of money he saved, which is 22. Okay? If he saved for 10 weeks, 11 times 10, which is 110, would be the amount of money that he saved. So I want to kind of combine these by multiplying them. And I'm going to get 11x is the amount of money Bart saves total. And now I'm going to say, all right, it says, what is the least amount of money? Least is, if I say you need to be at least 18 to vote, you have to be 18 or greater. So you need to be greater than or equal to 18. He needs greater than or equal to this amount of money, $345. And how is he going to get that money? Well, he's already saved 37 bucks. So I have that, plus he makes $11 per week times X weeks. So now I have my 11X. Very, very similar setup. I have some amount of money that he saved. Or in the last case, I have some amount of pounds that were already on the elevator, plus 150 times the number of people, plus 11 weeks times the amount of money he needs to save each week. It's the same type of setup. All right, we're going to subtract 37 from both sides. So we get 11x is greater than or equal to, just want to make that neater, greater than or equal to 345 minus 37 is 3, what is that? Oh, 8. Yep. And divide by 11. And I'll admit to you, I'm not going to do that in my head. So I'm going to, I got the calculator up. So we have 308 divided by 11, which is equal to 28. So X has to be greater than or equal to 28. So he has to save at least $28 each week. So Bart, and this time there's nothing fancy really to do here. It's X is greater than or equal to 28. He's got to save at least $28 per week. X is what the amount of money he saves per week. That's going to answer the question. All right, number 19. This one's a little trickier. Actually, we did this one in class, but why not do it again? So Chris wants to order DVDs over the internet. Each DVD costs $15.99, and shipping for the entire order is $9.99. So what happens is, when you order from the internet, sometimes the person who you're buying from or the company that you're buying from will charge you to send something to your house. So when the FedEx man comes or the UPS man comes, that costs money. That guy has to work or the woman has to work. That they have to run the truck and all that stuff. So shipping costs money. Chris has no more than $100 to spend. Okay. How many DVDs can Chris order without exceeding his $100 limit? Justify your answer. It's a word problem. So let's see. Each DVD costs $15.99. So $15.99 is the cost of each DVD. Okay. He's got to pay $9.99 shipping. Cost of shipping. And that's in dollars. Okay. He has no more than $100 to spend. So $100, that's the total of what he can spend. total money Chris can spend. Okay. The question is, how many DVDs can Chris order? That's our X. X is the number of DVDs Chris can order. Now, that's not money. Everything else is money. How do I tie this together? Well, I have my $15.99 for each DVD. So for example, if I wanted to buy 10 DVDs, I would do $15.99 times 10. If I have X DVDs, I'm going to do $15.99 times X. That'll be the cost of X DVDs. All right? Now I have to figure out no more than 100. I can't spend any more than 100. That's less than or equal to 100. We've done no more than like several times in this video. Now, what am I paying for? Well, I got to pay for my DVDs. So that's 15.99x. Plus, I have to remember to have money available for shipping. And there's my inequality. Now we can solve it. Subtract $9.99 from both sides. And so I get 15.99x is less than or equal to 90.01. And now I'm going to divide by 15.99. And so x is less than or equal to that number. I'm going to have 90.01 divided by 15.99. And that equals 5.62914, blah, 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 blah. So I'm going to put that up here. I'll put it down here. Okay? So x, hey, sorry, hold on. There we go. X is less than or equal to this number, 5.629143215. So here's my number line. Okay? I have 0 and I have 5.62, blah, 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 blah. And x has to be less than or equal to that. But x is the number of DVDs. I can't buy 0.62 of a DVD. So I have to decide, am I going to buy 6 DVDs or am I going to be able to buy 5 DVDs? And if you look at the number line, 5 is in the number line, and the shaded part, and 6 is not. We can't buy 6 DVDs. We can only buy 5 because we need to be less than 5.62. So we can only buy 5 DVDs or less. Okay? So you can buy less than 5 DVDs, but 5 is the maximum. You can't buy 6. And I know 5.62 rounds to 6. But watch this. If we were to buy 6 DVDs, there's a problem. And here's the problem. I have to pay $9.99 for shipping plus $15.99 times 6 DVDs. If I figure out what this is, $9.99 plus $15.99 times 6, I get $105.93. This is over my limit of 100. I'm over the limit of 100. 6 is too many DVDs. It's just too many. If I did 5 DVDs, okay, I want to go back up here and change this. Instead of a 6, if I did 5 DVDs, I would pay only $89.94. $89.94, not over the limit. So I only can pay for 5 or fewer DVDs. Okay? All right, one more, I believe. Here it is. This is a tougher one. 47 fewer boys than girls attend a school. Here's our standard type word problem. I have a sentence that I need to translate. 47 fewer boys than girls attend school. Girls is coming at the end, so girls I'm going to call X. X is number of girls in the school. 47 fewer than x is just like a less than. So another way to write fewer is less than. I have to translate as x minus 47, and that's number of boys in school. If the school has at most 925 students in attendance, it says find the greatest number of boys and the greatest number of girls who can attend. Well, at most, if I say to you, you can miss at most one homework this quarter, that means that you can miss 0 homeworks or 1 homework, but you can't miss any more than that. So you can miss less than or equal to 1. So at most is another way to say less than or equal to. So less than or equal to 925 is my school attendance. Well, who attends school? Guess what, guys? It's just boys and girls. So my boys are x minus 47. My girls are x, and I'll add them together. That's the number of boys and girls. That's the total number of students who attend school. And now we have an inequality, and we can solve it. X minus 47 plus x is 2x. I'll add 47 to both sides. I get 2x is less than or equal to 972 divided by 2. And x is less than or equal to, let's see, 960 divided by 2 is 480, and another 12 divided by 2, so it's 486. Okay? So x is less than or equal to 486. So I can have 486 fewer number of girls. So I can have 486 girls in the school. Okay? And 486 minus 47, I look back to my setup for the number of boys. 486 minus 47, which is 445. Nope, that's wrong. Sorry, not 445, 439. 439 boys in the school. And that's it for this video.